what's up, how you doing? Hamish, but a lot of people sometimes they like to call me 25 bacteria, nah, river soldier. You know, I was a child soldier when I was a baby, you know what I'm saying? So, no waste time, let's go to the business, right? You FaceTime, look, there's a lot of new ones here right now, man. The new team, you know what I'm saying? So if you're new to my channel, you come right here, see right here, click the subscription, and then before you get started, there we go. So now let's say consider the following diagram means they give you this diagram. Now, let me start for the third one. You know what I'm saying? So we can have a space and then move up, move up, move up a little bit, okay? Now, so let's say here, this one. Draw the graphical representation of the following inequality. Okay, so now let's start with this one, easy. So now I'm going to start with this one. So first and foremost, you want to get x-intercept and y-intercept. Now let's go draw a graph. Okay, so let's do a graph roughly. Excuse me. So now x minus y greater than 2. So first and foremost, get x and y-intercept. So you're going to say get x and y-intercept. So say here, the question x minus y greater 2. So you're going to say when x is intercept, when graph cut at x, value of y equal to 0. So what are those coordinates? Now, when x intercept, y equal to 0. So it's going to be x, 0, 2. It's going to be when x equal to 2 because it's going to be 0. So x, y equal to 0. It's going to be x minus 0 is x. 2 is going to be. Okay, cool. Now, so that's x intercept. For y intercept, when y is intercept, x equal to 0. So x is going to be equal to 0. So we're going to have a negative y here. Equal to 2. Don't worry about this, just say equal to. Divide by negative 1, divide by negative 1. So this and this cancel. Negative and negative cancel because you get. What am I doing? Okay, cool. So when y intercept, x equal to 0. So 0. So we're going to have a negative y here. Equal to 2. Don't worry about this for now. So divide by negative 1 because we don't need negative. Divide by negative 1, this and this cancel. So y equal to negative 2. So this is y equal to negative 2, x equal to 0. Oh, so now we have a coordinate of this, the first one. So which are these? When x intercept equals 2. So let's say this is 2. Let's just show this is 2. X equal 2, excuse me. Let's say equal 2. And y equal to negative 2 means this graph, if it continue, means it's going to be somewhere here negative 2. But we don't need this. We only need the positive side. So this could be something like this. But we don't need the negative side of the graph. Never. Most of the time. For this type of graph. But for the other graph, yes. But for inequality, don't bother. But let's just write for the fun of. No problem. Let's write. Now, we'll go for this one now. We'll do the same thing. X plus 2y. No, I'm wrong. Excuse me. You know why I'm wrong? Because since this is not double, only when it's like this or when it's like this, when you draw solid line. But for this case, since this is single, means you exclude, it must be dot line. Yeah, it must be dot dot. So make sure you draw dot dot. And then you must allocate, like saying, oh, this is the line of equation of x minus y greater than 2. Okay, cool. Now we go for the next one. For the next one, okay, 2 plus x plus 2y is greater than negative 2. So we do the same again. When x intercept, y equal to 0. So it's going to be 0. So it's going to be x, 0. So it's going to be x equal to negative 2, y equal to, because this is going to be 0. So x equal to negative 2. Now we go for y-intercept, x equal to 0. Now we want to get the value of y. So 0, so it's going to be 2y equal to negative 2 divided by 2 divided by 2, negative 1. Okay, cool. So x-intercept equal to, oh, let me say it again for other people. So when y-intercept, x equal to 0. So this is going to be 0 divided by 2 divided by 2, negative 1, negative 1. So we have a x-intercept, negative 2 and 0. Negative 2 and 0. Oh, negative 2 and 0. X negative 2. In this side here. Somewhere here. So this negative 2 and 0. And y equal to 0, negative 1. 0, negative 1. 0, negative 1 somewhere here. Now I'm saying, so this graph might come something like this. You know what I'm saying? And it's solid. You know why it's solid? Because of this. So it's solid line. Okay, now we go. So for that case now, we have to allocate same equation of what equation? X plus 2y e greater or equal to -2. So now we're going to have to test. Take any point above the line and take any point below the line. So if I had to take any point above the line, even 0, 0 is above the line. Look, this my line is even 0, 0. Let me take 0, 0. You know, any point. I want to take easy point. I don't want to put myself in tough situation. Or you could have taken, okay, which coordinate was this? This was 2, right? Yeah, it was 2. -2. So 2. I could say 2 and 1. Oh, because x equal to 2 and y equal to 1. Also is above the line. So you can take any points above the line. So I can either take this or that, or below the line, whichever you want. So now I'm going to take this coordinate and substitute in this line. But what is this line? This line is x minus 1 equal to 2, greater than 2. Now let's test to see if it's equal to 2. So either one, either this or this. 2 and 1, okay. Okay, I'll say 2 and 1. Okay, 2 and 1. So I'm going to take coordinate 2 and 1 and substitute in that equation. What is the x? X equal to 2 minus y. What is 1? Y equal to 1. We want to see if it's going to be greater than 2. Is it 2 is going to be greater than 2? Let's see. 2 minus 1 equal to 1. Is 1 greater than 2? No, it's not true. So if it's not true, it means we're not going to shade where we got the point, because this point is not valid. It's not true. So for that case, we shade opposite side. So I'm going to shade here. Because this is true now. Because if that one is not true, even if you say 0, 0, because if 0, 0 above there, this line is the point above the low. What's going to be 0 and 0? Is 0 and 0 greater than 2? No, it's not true. So that's why we don't shade on top, we shade opposite direction. Now, we do the same game now for this line. Okay, so what is this line? This line is x, y greater than 2. So let's take a point which either above or under. So me personally, I'll take this point, let's say 0, 0. Because 0, 0 is above this line here. You can take any coordinate. Now I'm saying you can say maybe 1 and 1. We can say 1 and 1 means x1, y1, whichever you want. Or you can take a point below, but this is going to be easy for me. So I'm going to say, okay. Now let's put it in. So what is the x? X equal to 1 plus 2 times y. Y equal to 1. Now this is going to give us 3. Is 3 greater or equal to -2? Yes, it's true. So for that case, we're going to shade what? On top. It's true because 3 is greater than -2. So for that case, now we're going to shade on top. So how are we going to shade? Look. On top of this line, look. From where the line goes. Okay. Okay. Okay, so now we're going to see the region where they intersect together. Where the region they intersect together. This is a region where they have something common. So I didn't need this. Where they intersect, if that's what you want. So it means I don't need this. You see here is where they have something together, they bind together. So even this one I don't need it. This is what I was looking for. Know what I'm saying? So the graph should be like this. This how it should be like. This is where they intersect. That's what you want the most. Know what I'm saying? So you can even raise this because you don't need this. This shading here. The shading that you need is where they intersect. Like you see here, this one went down and this one went this way. I believe you understand what I'm saying. This one went down and this one went. This was like they fold one another. But here there was no any intersection, so that's not common region. So you can see this. So if I had to draw again in the easy way, I could have said my graph would be like this. 2, 2, -2, and 0, and 2 and 0. Okay, now these chose negative. What? I can't remember. Okay, this one chose 2, 2 and 2, positive 2. Yeah, I can even check it. Positive 2, okay. -1 because this one x is 0. Okay, so -1. Or positive 2. Positive 2 and -2, excuse me. And -2 apart. -2. So look. So what I needed, and this it was like this, -1, so it's like. So this is a region where they intersect. You see here, this is where they both intersect. Because this one went up and this one went down. You know what I'm saying? And make sure you allocate their equation. This is x plus 2y greater or equal to -2. And this, oh, it's dot dot, excuse me. This is dot dot, my apologies. Dot dot, this is dot dot. So you gotta be very careful. If it's a multiple choice, you have to look. You know why it's dot dot? Because this is single. So you must look, oh, this is dot dot. This has to be dot dot. You know what I'm saying? So you must be very, very careful if it's multiple choice, because sometimes they might give a solid line and you see, oh, the answer is this, but it's not. You know what I'm saying? Because it has to be dot. Why is dot? Because it's single inequality. But if they're double like here, you see we put solid line. That's how you do. Sometimes they ask, okay, find this point of intersection. To find the point of intersection, it's easy. Sometimes they might ask you, find this point where they intersect. So you have to solve these two simultaneous, and this is how you do. Only if they ask you. But for this case, they didn't ask, they just say solve. So to get a point of intersection means these coordinates where these two things they intersect, okay? So now let me make x subject. So say x equal to 2. This one is gonna, so just say equal because you're just solving. This is gonna go over, it's gonna be plus what? Plus y. So I'm gonna take this and substitute in the second equation. I mean, this is the first equation, it give us this. And I'll take the value of x equal to, because take over, it's gonna be 2. I mean, this one go over, x equal to 1. So I'm gonna take this value here and put in another equation, I mean the second one. So it's going to be 2 plus, instead of say x, I'll say another value of x, 2 plus y, so say 2 plus y bracket plus my 2y, and then equal to -2. Now this is the 3y, so 2 plus 3, y equal to -2, this is going to give us, go over, 3y equal to, it's going to be this positive going to -4, divided by 3, this cancel, so y equal to 1.33, -1.33. So here, the value of x where they intersect, x is going to be -1.33. Now I want to get the value of y. To get the value of y means I want to take this value of x and substitute here where you made a subject at face. So this is going to be equal to 2 plus, what is a y? Y -1.333. -1.33. And this is going to give us, put in the calculator. So we say 2 minus 1.33. Okay, this is going to give us 0.67. 0.67. So our y equal to 0.67. 0.67. Yeah. 0.67. So when they intersect, x equal to negative, but a y equal to negative, I'm sorry man, this is a y. X equal to 6.7 because this is x. You see this is x. This is y. So y equal to -1.33, but x equal to 0.67. And it kind of makes sense because look. Okay, this is 2, this is 1, so this is 0.67, this is negative. Look. See? Because if this is 1 and this is 0.67, if this is -1 value of y, and if you go further, because this is the coordinate of y, -1.3. Okay, so which is this the same coordinate. So we're done with the A. Now we go for number 2. Let's make a space and do number 2. So where they intersect, that's your shared region, or sometimes you can call it feasible region, stuff like that. Now let's do, so I need a space for here. Man, I feel so faced, man. Almost 12 hours, not 12 hours, almost 17 hours I've been doing this stuff. Today, making a video. Tired now. I need to have a race and eat because I'm hungry. I've just been drinking only water, man. Only water. Can you believe it? I'm gonna draw my graph. I can draw a graph there, here, it doesn't matter, wherever. So, this is from here. So, draw my graph here. No, this is y and this is x. Now, x greater than 0 means x greater than 0. So this one, never mind. Don't stress about this. Focus on these. So when they say x the value of x is 8, means, let's say 8 is here. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So means it's going to be solid line. You know why it's solid? Because they're double. So I'm going to put solid line, which is going to cut at x. Cut at x. X equal to 8. A solid line vertical. Now we go y7, but this is dot at 7. Let's say this is 7. But it's dot. Why? Because, okay, so this is y equal to 7. Y7. But in back in your mind, you know it's excluding. That's why you just put what? That means you exclude. You're not including. But this was including. Okay, now we go. Now here we have to find x-intercept and y-intercept, just like how we did before. Now when x-intercept, y equal to 0. Y equal to 0. So y equal to 0 means it's going to be 2x equal to 10. Divided by 2, divided by 2. So it's going to be equal to 5. Now we go for y-intercept. When y-intercept, x equal to 0. So x equal to 0. So x times 0, 0. So y equal to 10. This is going to be 10. Now we come here, we do the same again. So this is for this equation. So I can allocate quick. X equal to 5. If this is 80, let's say this is 4. 5 is going to be somewhere here. 5 and 0. And that's 0 and 10. If this is 7, 8, 9, 10. If this is a rough sketch, so this will be 10. 0 and 10. So now I can just join this coordinate. You know what I'm saying? I can join this coordinate, but also I think I can get this coordinate. You know why? Because this is the equation of, let me allocate. So this is a equation of 2x plus y equal to 10. Don't worry about inequality, especially when you allocate. Equal to 10. So now, but we know at this point y equal to 7. At this coordinate here, y equal to 7. So if you put y equal to 7 here, it's going to be 2y plus 7 equal to 10. Okay? Equal to 10. Go over. So 2y equal to 10 minus 7 equal to 3. Divided by 2 divided by 2. So this is this constant. So y equal to 1.5. So y equal to 1.5. So here, x equal to, I mean to say x, man, what am I doing here? I think I made a mistake. I apologize. Wrong. Is 2y plus 2x plus y equal to 10. But y equal to 7 means this equal to 7. 2x plus y equal to 10. Oh, I think I was correct. 2x equal to, go over 3 divided by 2 divided by 2. So x equal to 1.5. X equal to 1.5. So this coordinate here, x equal to 1.5 and y equal to 7. Okay, cool. Now we go. So now we go for the last one. So we do the same game. X plus 2y, similar again. The same approach, okay? Okay, same approach. So when x is intercept, y equal to 0. So this is going to be 0, means 0. So x equal to 80. And when y is intercept, x equal to 0. I mean, this is going to be 0. So 2y equal to 8 divided by 2 divided by 2 equal to 4. You know what I'm saying? So now x equal to 80. X equal to 80. And what the value of y? Y equal to 4. Y equal to 4 somewhere here, let's say. Rough sketch. So 8 and 4. 8 and 4. So let's connect 8 and 4. So this is 4 and this is 8. So we come and connect here. This is a rough sketch, guys, like I say. So say this is the equation of x plus 2y equal to 8. Now, you see, at this coordinate here, see this coordinate here? Value of x equal to 8. Means I can put 8 here. So it's going to be 80 because you want to know value of y. But it's 0. Value of y equals 0. X equal to 8, y equal to 0. But we can do for funny. So x equal to 8 is going to be 80 plus 2y equal to 8. So go over to y equal to 8 minus 8 equal to 0 divided by 2 divided by 2. So y equal to 0. It makes sense. Y equal to 0. Okay. Now, we want to take a point now and shift left, shift right, shift where. Now let's start with this one here. Which is x equal to 8. So we're going to take a point left or right for this case, because for this one you cannot do up or bottom for this, because it's like vertical. So we either take a point up or, right or left. Now, if I take a point this side, look, this is 8. Let me take a point to 9. Anyway, it can be 9. Okay, is 9. Now I'm going to put here. It's true that 9 is bigger than 8. Not true. So it means we don't shade that side. We're going to shade this way. So I'm going to say, okay, so for that case, I'm not going to shade. Hold on. I say, how did I say again? I say I've taken this. X is less than 8. X less than 8. So we say, if I take any point, for example, here, we know this is x equal to 9. If I put 9 here, is 9 less or equal to 8? No, it's not true. So we don't shade this way, means we shade opposite direction, means we shade there. But this is meaningless. Okay, we can just do for fun, just a little. Okay? Because I want to get feasible region. Now, let me go for this one. Now, y. Okay, for y, we go, y is less than 7. So if it's less than 7, let's take a number either on top or bottom. If this is 7, let's take a 9 here. Or here, bottom, it doesn't matter. Okay, let me take a bottom, 6, let's say. Is true 6 less than 7? Oh, yes, 6 is less than 7. So if I take a point of y under, because these are y equal to 7. If I take a coordinate here, it's true. For example, y equal to 6 is true, means I have to shade under, means I have to shade here. So we can see here, this already, see, if this one comes, we have already seen this, there's a possibility this could be feasible region. Okay, now we go for this line, either here or here. If this line is going to shade there, because we want to know whether already they intersect with this, so we see already this might be the feasible region. But we don't know about this area here. Now, let me take this coordinate, this line, and take a coordinate maybe here or here. Let me take it below this line, like a 0, 0, because 0, 0 is going to be obvious. So I'm going to take this coordinate, which is 2x plus y, 2x plus y, return equal to 10. So if I take this line, let me take a coordinate below this line, like 0, 0, 0, 0 is below this line. So 2 times 0 equal to 0, plus 0, if it's greater than or equal to 10, no, it's not true. 0 is not bigger or equal to 10. So this is not true. So it's not true, we don't shade this, or we shade the opposite, it must be true. So if this is not true, means the other one, it must be true. Just simple as that. Like if this is not true, shade opposite direction. You don't have to taste, let me now take the one opposite direction. No, it's going to be true, obvious. So we don't shade this one, we shade opposite. You see now? So these are feasible region because all of them, they kind of intersect here. So I don't even have to shade there because this is where they intersect all of them. Now I'm going to come and look at this. So we know this by any means, for this to be true, this must be there. Now let's take a coordinate. Let's say the coordinate, okay. If this is 5, this 80, mean there's a possibility this could be 6. Let's say take 6 and this 4, let's say 6 and 2. 6 and 2 is going to be here. Now let's take 6 and 2. So we're going to say for this line, which line? X, okay, from here. X plus 2y, x plus 2y is greater than 80. Now let's see. Oh, I made a mistake, excuse me. 80, 80, 80, 80. Oh, this line here, my fault. This is a line, yeah. So then it's wrong because this line must be dot, dot, means this must be dot. So this must be dot. My apology, this must be dot line because this is excluding. Okay, so it must be dot. Now, let's go. So now, we want to test a point. We say any point maybe above or below. But I know this must be feasible just by looking. But let's just do for fun. So sometimes you have to be very quick in exam. You don't have to do other stuff sometimes to waste a lot of time. If you know the answer, you just do quick, you go. Because to get a distinction, there's a lot of things involved. So I'm going to say, okay, if I want to get a point above, look, if this is 5, this is 80, this could be 6. So 6 maybe and this 4 maybe 2, 6 and 2. So say take a point 6 and 2. X equal to 6, it's going to be 6 plus 2 times y equal to 4. This is going to be 10. Is 10 greater than 8? Yes, it's true. So if this is true, it means you have to shade on top. Look, this one does not have a friend. So this is the region where all of them they intersect. Can you see? So I don't have to bother with this because you see when it goes, this is the region I need. So this is my feasible region. I don't need even this other stuff. So this is my feasible region here. So even this I don't need. This is my feasible region. This. Okay, now we go. This x equal to 80, so here x equal to 80, and y equal to 7 here. Because look, y equal to 7, x equal to 2. And this is 18, 0, because this is going to be 18, y equal to 0, and this 5 is 0. No, it's not. This is the coordinate we need. So this is this coordinate, this coordinate, this coordinate, so this is our feasible region. You know what I'm saying? Yes. But also you can find the intersection, point of intersection, by taking this line and this line. You know what I'm saying? Only if they ask you to find the point of intersection. So for me, because you know, I always like to do things in extra, so let's just find the point of intersection of those two lines. So now I'm gonna say we got, so the question is done actually because this is a feasible region. So the only point we don't have a one feasible point. So I'm gonna say take this equation, 2x plus y equal to 10, because this line is going to intersect with this line, x plus 2y equal to 8. So I can solve this, you know what I'm saying? I can solve this. There's a lot of ways you can solve. Either you can make subjects or you can solve by elimination. Let's make it subjects. So I can make a y subject for the first one. So if I take the first question, I'm going to say this can become, I can make y subjects, y equal to 10, this is going to go over, it's going to be minus 2x, and then this half here, we're going to substitute in the second equation. So x plus 2, what is a y? Y equal to 10 minus 2x equal to 8. So this is going to be x plus 20 minus 2 times, that's going to be 4, x equal to 8. Okay, now 20 go over, so it's going to be x minus 4, x equal to 28 minus 20 equal to negative 12, so this is going to be negative 3x equal to negative 12 divided by negative 3 divided by negative 3. This in this cancel. So x equal to positive 4, x equal to positive 4. So it makes a lot of sense. If this 5, this will be 4. So the value of x equal to 4. Can you see? This is 5 here. So if you step back a little bit, x equal to 4. I want to get the value of y. To get the value of y is easy because what I want to do, see this x you got? Come and substitute the one that you boxed it, the one you make subject. So y equal to 10 minus 2 times. What is the x? X equal to 4. We got it already. So y equal to 10 minus 2 times 4 equal to 80. So y equal to 2. So y equal to 2. Y equal to 2. Make a lot of sense. Mean this y equal to 2. Make it because of this 4, 2, 0. Yes. 4, 2. So we have all the feasible points. Just in case if they ask you, okay, give us all the feasible points. Feasible point is 8 is 0, 8, 7, 1.5 is 7, and 4.2. That's our feasible points. You know what I'm saying? So we're done with that question, which we're going to use those feasible points, and this is a feasible region here. This is feasible region. Okay, now let's go for the first equation, which is easy go. Easy go. Just erase something. No problem, it's fine. So we have to represent this inequality above. No one, I erased it by mistake, but it's not a big deal. You just have to represent the inequality above, and then we go with them. Drink a little water, sorry. Thank you. Here we go. Let's go, quick. Let's go, man. Let's go. Sit down. What you gonna do? What you gonna do? What you gonna do when they look for you? What you gonna do? What you gonna do when people look for you? What you gonna do? What you gonna do to get distinction? What you gonna do? Get 100. Get 100, man. Don't get this 90, 86. Man, come on, man. Only loser get 80. Okay, cool. So let's say consider the following diagram. So we have a diagram that says derive the inequality that represents the above diagram. It's very easy. So something you should know. Whenever you have a solid, this means inclusive. Or inclusive or including. And this tells you excluding. For example, if somebody give you like that, so that you tell, it starts from 4, so 4, 4, but it's including. So if it's including, you can say like this, from 4 all the way to 9, but 9 is excluding. So it's excluding right like that, to 9. And then 6 is x, you put x at the middle. So that's how it represent. So not all the time they're going to give like, they might give stuff like this, for example. Yeah. Let's say they might say 4, okay. Now they draw something else here. Let's say they draw stuff like this, let's say. Okay, together. So we're gonna say, oh, so it starts from 4 to 9, and then there was a gap. Okay, let's say this is 11. Let's say this is 11. So all this stuff, we do like this. And then it's kind of union with x, but this x is bigger or greater than 11. So including 11. So this x is greater or equal to 11. But including. You know what I'm saying? So you can say like that. And here you must make sure you say, before you say, they say x are element of real number. X are element of real number, whereby it starts from 4 all the way to 9. Also, or union means, or after that, you continue from 11, but this x is greater than 11, including 11. That's what I put including here. But here it was excluding, that's what I put excluding. So sometimes they will give stuff like this, for example. Say, have a number line here. Let's say we got 2 number line. Man, this stuff is easy, man. I'm supposed to do this stuff. Okay, let's say this is 0, -1, -2, -3, -4. Okay, so 1, 2, 3, 4. Okay, now this give you stuff like, let's say this is stuff from yeah, stuff like this. So what I'm going to do here, there's a lot of ways you could do, okay? So I'm going to say, okay, so always start from the left. Always start from the left. You know what I'm saying? Can you see here, start from the left. You start on the left, including all the way. You start from the left, you go to right. So this stuff goes all the way to negative infinity because you don't know where it's going to stop. So you're going to say, oh, so I'm going to say x because this is x. Our element of real number, whereby this x is going to be less than -1 all the way. So, okay, so this x must be less, but excluding. So I'm not going to put 2 because just excluding than -1. But it's going to again unite with x greater or equal to 1. No. Because there's a 2 end for this case. So you must allocate 2 end because it's not like it's going all the way 1 all the way around. It kind of goes, excuse me, x is between -1 and 4. So I'm going to say this x is between, this is including, but this is excluding. This is 1, this is 4, and this is 1. So they can try to play around with your mind, you know what I'm saying? Let's take another one. Let's take something has to do with let's say they ask you unite, intersection, and stuff. Oh, another way. So what I've shown you is called set builder notation. This is set builder notation. Okay, even here set builder. So sometimes not necessarily you must allocate like this. Now let's see interval notation now. How do we represent the same thing by interval notation? Let's start from this alone first. So for set builder notation, if I start with this, if we exclude that, I'm going to say this including. If it's including, you write like this. Like this if it's including. But it's on the left, that's all right on left. Including 4, it goes all the way to 9. So you put comma, and then you put the last verb. But this is excluding because it does not include it, so you write like that. Like normal bracket, but this is square bracket or rectangle bracket. Square bracket, okay. Know what I'm saying? So now, if I want to put together, because this was for alone, this one here is start from including 11 and all the way to positive infinity. So write like this. But infinity, you don't know where exactly. That's why he's going to exclude, because do you know exactly where infinity? You don't know. That's why I'm going to put like that. So together, this all together means this and this is going to be all. So together of this is going to be start from including 4 all the way to 9 excluding, because this one is excluding, and then we're going to unite because it's continue, this including, but what 11 positive all the way to positive. So for interval notation, this is called interval notation. You must put where something starts, where something finishes. You must give 2 of them. So this is called interval notation. This is interval notation. Now let's come here for interval notation. So we're going to say, oh, so it's start from, so for interval notation here, interval. So how are we going to do? Oh, always start from the negative. So I start from negative infinity because I must give 2 coordinates. Not like here you say, oh, it's less than -1. No, for this case you must say, if it's less than -1, where exactly? Oh, it's going to be negative infinity because you start from the left. From the left. It's going to be negative infinity. But negative infinity you exclude because you don't know that coordinate of negative infinity. So negative infinity and then all the way to -1. But -1 also is excluding. So if it's excluding, put it like this. And then we're going to unite, means also continue from, this is including, so we're going to include 1 and then all the way to 4. But this is excluding. You know what I'm saying? So this is interval notation and this is set builder notation, but it does represent the same thing. This is interval notation. You know what I'm saying? So, man, you know what to do, man. You FaceTime, you click the subscription button, share to other people. Somebody might benefit from that. What you gonna do? I'm out.